Okay guys, this is actually an example from the theory which we have covered recently. So the problem goes like, or they say a bacteria population, we're dealing with a bacteria population N of T undergoing a natural growth. These are the keywords. Natural growth, they're just referring to exponential growth. Exponential growth. Bacteria population N of T undergo natural growth numbers 49 at 12 noon. Okay, so the initial statement is that the bacteria population N of T undergo a natural growth numbers 49 at noon. It means for your initial condition N of 0 is equals to what? N of 0 is equals to 49. Okay. At 12 noon, suppose there are 294 bacteria at 1 p.m. Derive a formula giving N of T after T hours. T hours. So it means N of what? N of 1 is equals to 294. One might wonder, why am I saying N of 1? It's because we were told initially at 12 noon we had how many bacteria? We had 49 again. So the difference, okay, and then the next thing they told us that at 1 p.m. we are having how much? 294. The reason I used 1 here is because we're having the difference from 12 noon to 1 p.m. is actually 1 hour. So that is the reason I'm using 1. If they said derive a formula giving N of T after T minutes, I was going to write N of 60. So they said we must derive a formula giving N of T after T hours. So we are going to use 1 hour instead of 60 minutes. So we are required to derive a formula, meaning we must write N of T is equals to something. We are required to write N of T is equals to something. We are required to write N of T is equals to something after T hours. So let's start. We have a natural growth. What does natural growth mean? Natural growth, it implies or we're dealing with what we call exponential growth. So the first thing we're going to write our formula, dn over dt, which is equals to kn. So if we separate our variable, we're going to have dn over n, which is equals to k dt. We integrate both sides. We're going to have ln of n, which is equals to kt plus c. Okay, so this is your formula, a general solution for natural growth again. Okay, cool. Remember, we're trying to get N of T is equals to something, right? And from the previous video, I said you're always going to use the IVP. You're going to use, this color is not visible, let me try another color. You're going to use the IVP to get the value of what? The value of C, and the BVP to get the value of what? Of K. So now we're having the ln of n is equals to kt plus c. This is what we have. Going back to right. This is what we have. What do we do next? We're going to get the value of c. How are we going to get the value of c? By using the initial condition, which is n of 0 is equals to 49. It means when time is 0, n is 49. n is 49. So let's substitute. Ln of 49 is equals to k into 0 plus c. This implies that c is equals to ln of 49. The value of c is 49. Okay, we have got the value of c using the IVP. Now let's try to get the value of k. How are we going to get the value of k? If we come here and try to get the value of k using this condition, we're going to have two unknowns, because we're going to have one as time and 294 as n, but then we're not going to have c. So before we get the value of c, we need to substitute c back into this equation. So we're going to say ln of n, which is equals to kt, plus c, which is ln of what? Ln of 49. And then now we can get the value of k by substituting our BVP, which is n of 1 is equals to 294. If we substitute n of 1, which is equals to 294, we're going to get the ln of what? The ln of 2. Let me just write from the next line. Let me just write from the next slide. We're going to get ln of 1, ln of 294, which is equals to k plus ln of 49. If we simplify this, we're going to get k, which will be equals to ln of 294 over 49, which will be equals to ln of 6. So k is equals to ln of 6. We have got the value of k and the value of c. But remember what the question says. It says we must derive a formula n of t. So to avoid the confusion and too much complex algebra, let's use the original formula to determine n of t in terms of k and in terms of k and c. Then at the end we're going to substitute the value of c and k. So if we're having ln of what? If we're having ln of n, which is equals to k t plus c, we can simplify this by multiplying by e, and then we're going to have n to the exponent e to the exponent kt, which is being multiplied by e to the exponent c. And we know that e to the exponent c is the same as, it's a constant, we can replace it by k, understand? But for now, let's just leave it like that. So now let's replace the value of k and the value of c. If we replace the value of k, we're going to have, if we replace the value of c, we're going to have e to the exponent ln of what? Ln of 49, which is being multiplied by e to the exponent, the e to the exponent ln of 6, which is being multiplied by t. And then in short, we're going to have n, which is equals to e ln of 49 multiplied by e t ln of 6. Therefore, we can simplify this by saying we have 49 e to the exponent t ln of 6. I'm just playing around with the algebra here. So your final answer is going to be n of t, which is equals to 49 e to the exponent t ln of 6. This is going to be your final answer, what you are required to solve here. They said you must determine what n of t. This is the formula which they are looking for, understand? So let's move to the next question. The next question, they say how many bacteria are there at 140? How many bacteria are there at 140? So you need to ask yourself, from 12 noon to 140, how many minutes? We have 1 hour, which is going to be 60 minutes, plus that 40 minutes. 1 hour plus 40 minutes. It means we are going to have 100 minutes. But remember, we are dealing with what? With hours. So we're going to divide that 100 by 60 in order to get hours. If we divide 100 with 60, we're going to get 5 over 3 hours. I'm avoiding to write the commas. 1.66 is to avoid making mistakes, so I'm going to work with fractions. So you're going to have 5 over 3 hours. Let's go back to the question. How many bacteria are there at 140? So what is n when time is 5 over 3 hours? They're looking for n when time is 5 over 3 hours. We have already calculated the formula for n of t. So they're looking for n. They're looking for n when time is 5 over 3, and then we're going to substitute t with 5 over 3 ln of 6, and then let's press our calculator. 49 times e to the exponent 5 over 3 ln of 6, you're going to get 970, 76, which is approximately 971 bacteria. The reason I'm writing it as a whole now is because you can see you have half people. I have half student. Like you can't say already. You have one person, not half person. Half person, understand? Like bacteria, I can't say, well, I have a cow and a half. You have 2 cows, 3 cows. You must always write to estimate to the nearest whole number. So you're going to have 971 bacteria after 5 over 3 hours. And then the last question, they said, at what time? They're looking for time when what? Will there be 20 bacteria? 20,000 bacteria. This represents the value of n. It means n is going to be what? 20,000, and then t is unknown. So we're looking for the value of n when t is unknown. Meaning we're looking for t when n is equals to 20,000. When n is equals to 20,000, 21, 23. And we already calculated the formula for n of t, which is equals to 49 t ln of 6. So we can actually please 20,000 where you see n of t, and when you see time, just leave it as t, because that is what we're looking for. So let's do the math here. Can actually divide 20,000 by 49. If you divide 20 1, 2, 3 by 49, we're going to have 20,000 1, 2, 3 over 49, which is equals to e t ln of 6. Okay, and then let's multiply by ln to get rid of this base here. Going to have the ln of 20,000 over 49, which is equals to t ln of 6, and then we divide by ln of 6, divide the whole thing by ln of 6. This implies that time will be what? Ln of 20,000 divided by 49 over ln of 6. Your time is going to be 3.3 2.355 hours. And from the question they said at what time, to the nearest what, to the nearest minutes, will they be 20,000 bacteria. So it means we need to convert this 3.3555 hours to minutes. How can we convert this? We're going to convert this by multiplying the whole answer by 60. So it's going to be answer multiplied by 60, which will be where we're going to have our T as 201.31 minutes. You can just approximate it to 201 minutes. This is the final answer.